All right, let's talk about something that, I'm going to be honest, trips up pretty much everyone at some point, even the pros. We're talking about degrees of freedom. And I know, it sounds super technical, right? But forget all the complex math for a second. At its core, it's actually a really simple, kind of beautiful idea about information and choice. And trust me, once you get it, you'll start seeing it everywhere. So we're going to kick things off with a mystery that has probably haunted you since your very first stats class. You know the one. It's that moment where the professor writes something on the board and everyone just kind of stops and thinks, wait, hold on, why? Why are we doing that? And boom, there it is. The infamous n minus 1. Why on earth do we subtract 1 before we divide? I mean, it feels totally random, right? Like someone just made it up. But it's not. In fact, the reason why is one of the coolest, most elegant ideas in all of statistics. Seriously. And that's exactly what we're going to unpack today. We're going to focus on the one core idea that doesn't just solve that n-1 mystery, but it also shines a light on how a ton of common statistical tests actually work. So we're skipping the heavy, boring formulas. We're just going to focus on the simple, intuitive logic of choice. Okay, so to solve that whole n-1 thing, we've got to get to the heart of the concept itself. I mean, what does freedom even mean when we're talking about stats? Let's break it down. Okay, take a look at the official definition here. There are two parts that are absolutely key. You see them? Free to vary and satisfying a specific condition. Honestly, that's the whole shebang right there. It's all about how much wiggle room, how much flexibility you have when you're forced to play by a certain rule. Or let's make it even simpler. Think of it like this. Degrees of freedom is just the number of independent choices you actually get to make. And every rule you have to follow, we call that a constraint in stats. Well, it takes away one of your choices. So the more rules, the more constraints you have, the less freedom you have. It really is that straightforward. All right, enough with the theory. I promise this is going to be your aha moment. I'm going to walk you through a super simple puzzle that will make this entire idea just click. Ready? This is where it all comes together. Okay, so here's the deal. The puzzle is simple. I need 3 numbers from you, but there's one rule, just one constraint. Their average has to be 10, which, means their sum has to be 30. So let's play. Go ahead, pick the first number, anything you want. Let's say you pick 8. Perfect. Okay, now pick the second number. Again, complete freedom. How about 12? Cool. So far we've got 8 and 12, which adds up to 20. Now, what about that third and final number? Do you have a choice? Think about it. Nope, you have no choice at all. To hit our target of 30, that last number is totally locked in. It must be 10. Your freedom just ran out. And that's it. That is literally the entire concept in a nutshell. We had 3 numbers to work with, right? But because of that one single rule, that one constraint about the average, only 2 of them were actually free to vary. We only had 2 real independent choices. That constraint forced our hand on the last one. So in this little puzzle, we had 2 degrees of freedom. And this brings us right to the general rule. It's so simple. Degrees of freedom is just your total number of observations minus the number of constraints. So in our puzzle, we had 3 total observations, or 3 numbers, and we had 1 constraint. The average had to be 10. So 3 minus 1 gives us 2 degrees of freedom. See? It's the same thing. Okay, I hope you had that aha moment, because now we're going to take that little puzzle and connect it all the way back to our original mystery, the whole n-1 thing. You're about to see how this one simple idea is like the master key that unlocks the logic behind a whole bunch of statistical tests. And here it is, the big reveal. Look at that top row for sample variance. To even calculate variance, what's the first thing you need? You need the sample mean. Well, guess what? That sample mean acts as a constraint, exactly like the average of 10 did in our puzzle. Once you've calculated and fixed that mean, you've used up one piece of information. You've lost 1 degree of freedom, and that is why we divide by n-1. It's not arbitrary at all. And hey, look, the same logic applies to a t-test. Now, check out simple regression. In that case, we have to estimate 2 things, a slope and an intercept. That's 2 constraints. So what happens? We lose 2 degrees of freedom, and the formula becomes n-2. It's the same beautiful, simple logic every single time. So, okay, we've solved the puzzle, but you might be thinking, so what? Why does this actually matter when I'm working with real data? Well, this is way more than just some academic detail. Getting this right or wrong has a massive impact on whether your conclusions are actually valid. Look, getting the degrees of freedom right is absolutely critical for everything that comes next. It's what makes sure the statistical distributions we rely on have the right shape. And if that's right, it means our confidence intervals and our p-values are going to be accurate. But if you get it wrong, your estimates get all biased and your conclusions could be completely worthless. To put it simply, getting this right is like making sure the foundation of a building is solid. It ensures your entire analysis doesn't just crumble. So from now on, whenever you see n-1 in a formula, I hope you don't just see a bunch of symbols. I hope you see the story behind it, a story about freedom and choices and constraints, all working together to make our stats more honest and reliable. And that's really the magic of it, right? Moving from just knowing what to do to truly understanding why you're doing it. So the only question left for you is, what's the next statistical mystery you're ready to solve?